Dear students, today I am going to explain about functional dependencies in module 4. Already in the last class, we have discussed about the informal design guidelines of relation schemas. The 4 design guidelines we have seen. Okay, the semantics of the attributes should be clear, and then next attributes should avoid the insertion, deletion, updation anomalies, and reduce the null values, and then avoid the spurious tuples. So that is that 4 things are the informal design guidelines. Now that function dependency is the formal design guideline for relation schema. Now we are going to define what is meant by functional dependency and how it will be used with example, and what are the different types of functional dependency under this PPT. Functional dependencies. Functional dependencies are used for specify formal measures, that is goodness of relation designs. So the functional dependencies and keys are used to define normal forms for relations. So for that purpose only we are defining these functional dependencies. So functional dependencies are constraints that are derived from the meaning and interrelationships of the data attributes. Okay, so suppose a set of attributes x functionally determines a set of attributes y if the value of x determines a unique value for y. That's the reason we have taken. Suppose we'll take SSN. If it defines that all other attributes of a relation, and that student relation means that SSN functionally determines other attributes, we can take. So, for example, if x determines y holds if whenever two tuples have the same value for x, if same value for x means they must have same value for y. For example, if two students USN is same means their names should be same. For any two tuples T1 and T2 in any relation instance R of R, or instance we are going to call it as small r of capital R, if T1 of x is equal to T2 of x and T1 of y is equal to T2 of y. Okay, so x defines y in R specifies a constraint on all relation instances of R of R. Here we are taking relation state. Okay, so this is thing. So FDs are derived from the real world constraints on the attributes. So see here, so social security number SSN determines the name of an employee. Then project number we know, using that we can determine project name and project location. Okay, and then if we know the SSN and project number together, we can find out the hours. So here we can tell E name functionally depends on SSN attribute, or we can call it as SSN determines E name. So FD is the property of the attributes in the schema R. The constraints must hold every relation instant. So this we know that if K is a key of R, then K functionally determines all attributes in R. For example, if we will take employee relation, in that employee relation, that SSN is a key attribute. So if we know the SSN, we can find out all other attributes, name of the employee, address of the employee, date of birth of the employee, department of the employee, all other attributes we can determine from the SSN. Okay, so now that's the reason. So since we never have two distinct tuples with T1 of k equal to T2 of k. That is never it is possible, because the SSN is a key attribute that will be having unique value for each and every tuples present in the relation. So there are 3 different types of functional dependencies: full functional dependency, partial functional dependency, and transitive function dependency. So first we will see full functional dependency. So full functional dependency means a functional dependency x defines y is a full functional dependency if removal of any attribute A from x means that the dependency does not hold anymore. That means, for example, if we know the SSN and project number, we can find out how many hours the corresponding employee is working on the particular project. So this is a full functional dependency. Okay, if we know SSN alone, we can't find out how many hours the employee is working on the particular project. And also if we remove project SSN, project number also, we can't define how many hours the particular employee is working on the project. So that other two things are not hold. So this is called as full functional dependency. SSN comma P number defines hours as a full functional dependency. Okay, if we remove any attributes, it won't hold the dependency. The next one is partial functional dependency. So partial functional dependency means a functional dependency x defines y is a partial dependency if some attribute A belongs to x can be removed from X and the dependency still holds. So opposite to full functional dependency. Suppose for example SSN comma P number, if we know, we can find out the name of the employee. Partial, because if we know SSN alone also we can find out the employee name. So this is called as partial functional dependency. The next one is transitive functional dependency. From the name itself it is that transitive means, you know, if X defines Y, X equal to Y equal to Z means X is equal to Z. That is general transitive concept. So here we are applying the transitive concept in functional dependencies. So we have that X, Y, Z, 3 set of attributes. Then the transitive functional dependency R is defined as if X defines Y and Y defines Z means then X defines Z. That means if X functionally determines Y and Y functionally determines Z, then with X functionally determines Z. So for example, if we know SSN, we can find out the department manager SSN. If we know the SSN, we can find out the department number. If we know the department number, we can find out who is department manager SSN. So instead of that, we can directly hold, if we know the SSN of an employee, we can find out the manager SSN. Okay, so this is a transitive functional dependency. So these functional dependencies, why we are studying means these things are important to define the different types of normal forms. Okay, we are going to define first normal form, second normal form, third normal form and so on. There we are going to use partial dependency, full functional dependency, transitive dependency, etc. So for that you should be clear about partial, transitive and full. Full means if you remove any attribute, it won't satisfy that functional dependency. It won't hold that. Partial means if you remove, after removing ortho, it will satisfy the condition. Transitive means, you know, X defines Y, Y defines Z means then X defines Z. So that you should keep it in the mind. Okay. So the next class we are going to discuss about the normal forms. Okay. Thank you.